Thank you very much. So I come from Faculty of Electrical Engineering, and there I teach subjects on electronics development. And my research field is in electronics for photovoltaics. So totally different topic that you probably are familiar with, I suppose. I don't know. But my goal here was to show you some practical aspects of European products compliance. And since this is a cybersecurity conference, I put cybersecurity in the title. Okay, so let's start. Do we need standards? Of course, you will say yes, and yeah, we do need them. But nevertheless, even for such a simple device, such a wall socket, we have many standards. And why is that? Well, the world is big, and there are many people that want to enforce their own thoughts on what is the best socket for power outlet. And I like particularly this one. It's from Switzerland. And why is it so good? Because you can squeeze 3 plugs into a same socket, and by that, you're much more efficient. But this one has a problem, because you can just put halfway in, and you can touch the hot spot there, and you get electrified. So therefore, they say, okay, let's improve that and make recessed sockets. And those are safe to use, and they are really handy. So why don't we use them? Because in my opinion, these are the best sockets there are. Well, you've seen this slide today already. Yeah. So this is the story of our human history, I would say. We never agree on a single thing. You can see that in the latest elections, right? And what was the story in Europe? What is the story of the Europe? The Europe was founded all on the basis of a free market, free exchange of goods. And this was the story before year 1985. Some of you lived back then, right? Like myself. I was 10 years old. And this was the story of those days. You could, of course, sell your products across the Europe, but for each country you had to specifically comply to their rules, and you had to test for those rules. But back then, there were not a lot of electronic products. There were like TV sets, radio sets, and some radio communication equipment, but that was it. So after that, they found out that with the new electronics penetrating each on every segment of the market, they found out that this is not a good way to proceed, because every country having its own standards is just a nightmare for every producer. And therefore, after year 1985, they went to a new approach, they said. Well, new approach in 1985, okay, it's still new, they say. So now they all say, yeah, this is new approach. Okay, let's go for it. What is the key essence of this new approach? It's the, I hope this works. So the cable wasn't meeting the standards, it seems so. But I'll just stay still. So the new approach in European Union is the following. We have European Commission on one side, which is making the laws. The European Commission says, you should do this, and you shouldn't do this and that. How you do it, it's written in the standards. So you're obliged to follow the rules, the law, but the standards will tell you how to do it. And if these two are working together, so the European Commission and the standardization organizations are working together, they make so-called harmonized standards. And these are valid in the whole European Union. And if you follow the rules in harmonized standards, then you can put a CE mark on your product. Now check your phones, laptops, everything you have electronically, check if they have a CE mark. Even though they were made in USA or Japan or China, right? So what does that CE mark actually mean? It actually means, does it mean that your product is safe to use? Does it mean your product is compliant with the standards? Well, no. It is a single thing that says the producer who put the CE mark on the product is the responsible person if something goes wrong. That's it, nothing else. The CE mark doesn't say, oh, this product is safe. It is just a passport for the product to be sold within the European Union. And as I said, it states the responsibility of the manufacturer. All right, so let's look at this example. It's a power supply for a laptop. It has many marks on it, right? Some of those are valid for USA, some for China, some for Australia, and going on and on. And the one that is the important one for Europe is the only one here which is a CE mark. All the rest, well, they may be there or not, doesn't matter. Some of those are just quality marks, like TÜV Rheinland. Okay, this was tested in Germany, so it must be good. Right, so you mentioned the other CE mark, right? The China export mark. Well, it's very similar, but not exactly the same. And if you read the notes there, you will also see that it is indoor technology equipment. And the FCC mark is also not correct, and so on and so on. So when I bought this power supply, I almost got killed. And when I opened it, I saw exactly why. It was not made by the standards, even slightly. And it's not so hard to make the product according to standards. You just have to know a few things, and it will maybe cost a little bit more. And that's it. And the cost is usually the problem. So now, let's go into the European market regulations. They say these new approach directives, which are given by the European lawmaker, right? They ensure free movement of goods. For those goods that are sold within the European Union, they have to meet the health, safety, and the environmental standards. So these three things: health of people and animals, safety for people, animals, and the environmental effect. And in the field of electronics, we have those which I will show now. First, the electromagnetic compatibility. All devices have to work within each other's environment in such a way that do not affect the others. So all your laptops now, which you are eagerly typing on and trying to hack everyone around, those laptops have to work in this electromagnetic environment. And the next one is, what is written here? Low voltage directive. What is low voltage? Less than 5 volts? Less than 1.5 volt? Less than 1,000 volts? Well, we'll see. The low voltage directive is about safety. You probably noticed when I was carrying this laptop around that I didn't get killed, right? You noticed that. So it's not granted, right? The safety is not granted. It is by design. It is given by design, by safe design of products. Those two were lately joined into a radio directive, which is intended for radio devices, those who have radio transmitters and receivers. And this radio directive encounters, or let's say it encompasses the safety and EMC within a single directive. And it's intended just for wireless devices. Now, the European Union is a little bit strange in that sense, how they deal with this stuff, and you will see why. And lately, now we are also introducing Cyber Resilience Act, which is about cybersecurity of all connected devices you can find. All right, let's dive into these separate directives a little bit more deeper, starting with EMC. This is my specialty, so I will give a little bit more emphasis to that, but you will see it also deals with security a little bit. First of all, what does it cover? The EMC directive covers all devices that can produce electromagnetic noise, which means every device that has some current that flows in it at certain frequency. All right? That means all digital devices surely are covered by EMC. What else? These devices should have a case. So, like, development boards are not covered by EMC, but final products with a case, they are. What else? They had to deliver a function for an end user, and you should be able to buy those products in a free market. So these are all 4 prerequisites for a device that you can say, okay, I have to worry about the EMC of that device. And we call them finished appliances. These are finished appliances your grandmother can buy in supermarket. If it contains electronics, if it contains a case, if it gives a final, let's say, a function, then it has to comply with EMC. And which products do not fall under EMC are usually those who cannot produce electromagnetic noise, like resistors, heaters, light bulbs, batteries, cables, stuff like that. Radio devices. Well, radio devices should radiate electromagnetic noise by default, right? So we are covering those radio devices by different directive. What else? Aviation products, they have their own standards. The radio amateur devices, well, radio amateurs have to know what they're working with, otherwise they will lose their license. So that's why those should not, or they don't have to put a CE mark on the radio devices for radio amateurs. And this is my favorite, development systems that are built for research purposes. Those also don't need to have a CE mark for electromagnetic compatibility. So what do they check? Well, they check if the device, what is the radiation level of the device. They check how immune the device is to the radiation. They check how immune is the device against lightning strikes and other phenomena in the grid. And of course, how immune is the device if it is struck by electrostatic discharge, which means you touching something and the spark jumps on the device. It shouldn't reset, it shouldn't be destroyed or stuff related to that. So a little bit more about EMC. For example, the EMC is always about 2 devices, the aggressor and the victim. Imagine aggressor is a computer, and the victim might be your audio system. And then the computer can radiate electromagnetic noise, and you can hear it in your speakers. What else? You can connect your mouse to a computer, and when you move your mouse, it will radiate because the signal will travel through the cables, and your computer or your audio system will pick up this noise, and you would hear every move of your mouse in the speakers. This is a real thing. What else? Well, you can plug your devices into wall sockets, and then your noise can travel through the cables, and the cables can radiate. And then this noise can travel through the grid, and then the noise can come to the other socket and travel back to your victim side. And of course, you have grid, you have weather phenomena, and these weather phenomena can cause lightning strikes and stuff that can couple to the devices by themselves. So let's see and try to answer this question. You all know this blue thing, right? You've heard about Arduinos, right? You use them a lot, do you? Do Arduinos, are they a finished appliances? The question to you. Can you buy them in supermarket? But you can buy them online, right? So they are on the market. Do they deliver a function? They do. Do they contain high-frequency components? So they should be compliant with EMC. Why? They don't have a case. So people use Arduinos a lot as a development board, but then they put them into a case because they want to sell products around the world using Arduinos inside as the heart of the product. And then we have a problem, because no Arduino till now met the EMC standards. No one. I didn't see an Arduino that would be compatible with EMC. Think about it. Whenever you make a product and you put Arduino inside, you will have to deal with EMC issues. How hard would it be for an engineer to design a board that would be compliant with electromagnetic noise levels? Not very hard, but then it would be expensive. A little bit expensive, that's it. A little bit filtering, and you could deal with the issue. But every filter costs money, and therefore they don't have it. Okay, let me show you another EMC issue in reality. Two chargers, one is white, the other is black. Which one you think is compliant? The white one or the black one? Okay, raise your hands for the white one. How many of you think the white one is compliant with EMC? Okay, 40. For the black one? Okay, less than 40, 2, 3, 5. Okay, you're right. The black one is the nasty one. So, you see the white one was made by Samsung, right? And the black one is just no-name cheap sheet from Temu. And I tested a lot of power supplies bought by students from AliExpress and other, and every single no-name power supply for phone chargers was all over the limits. And I'm talking about 100 times over the legal safety limits. Think about that. So you could see immediately why it's so. Because the black one is twice as lighter than the white one, because it doesn't contain any filtering components. Okay, so can EMC pose a health risk? Well, does it? This black cat here is very, very happy when it is exposed to 100,000 watts per square meter. It is sunbathing and doesn't have an issue. And of course, you at 100,000 watts per square meter wouldn't be so happy for many hours, right? You would get sunburned. But at 100 watts per square meter, it's quite nice. You know, light is electromagnetic radiation, as we know. So we said in Europe, okay, let's make a safety level of 10 watts per square meter. This is barely noticeable. And say, okay, let's make a legal even lower, because safety is something, right? Safety level. But the legal should be lower than that. Okay, so they calculated, because you know, we detect power. That's what we see. That's what we feel is the power. But measuring that power is quite hard. So we rather measure voltage or voltage electric fields, because it's easier to make an electric field antenna than a power detector. So our politicians found out that, okay, let's go 10 times lower, right? They went 10 times lower. But 10 times lower in voltage means how much? 100 times lower in power, which is a fail, I would say. And we have really, really low power levels that are legal limits for all the radiation of electronic devices. What about EMC? The EMC levels are roughly 1,000,000 times lower than that. The EMC levels are in the range of 1 microwatt per square meter. Why? Because devices are much more sensitive to the electromagnetic noise than people, especially radio receivers. And we don't want to mess with those. So if you want the radio to work next to your computer, the levels must be really, really low. So don't worry about electromagnetic noise for health. So what is EMC really about? Well, I hope we have sound, but no, we don't. So I have to make the noise now. This is what we would hear here. And now we are approaching the radio. That's what we would hear in this radio receiver. Just because of one single small non-compliant power supply of for phone. Let's think about cars. In cars now we have like hundreds, 200 microprocessors all packed in 2 square meters. And they have to operate within each other without failure. And imagine when you press a brake and your braking lights go on, that that can happen. Therefore, we want EMC to be followed, especially in safety critical applications like cars, airplanes, medical devices, and stuff like that. Can EMC pose a security risk? You've seen movies, right? And you've seen some bad guys shutting down half of the city with an EMP bomb, which is electromagnetic pulse bomb. Is this a real thing? No. Not really, not in that sense. But we have EMP bombs. We have EMP sources that can radiate really in narrow angle, and you can hit a drone with it, and you can shut it down. But what are real EMC, realistic EMC threats are nuclear explosions. If a nuclear explosion is very high in the air, it will not blast by force, it will blast by electromagnetic pulse. And that would destroy the electronics or just make it partially not working, let's say. It depends on the immunity of the electronics itself. And the other one is solar flares, which may interfere when they are highly intensive, may interfere with electronics on Earth, and it may cause shutdown of communications or even destroying some satellites, or maybe causing some blackouts. So these are 2 main EMC threats. We are actually dealing with it. Okay, the nuclear explosion, we'll see, I don't know. But the solar flares, these are real things. So enough about EMC. Let's go to the low voltage directive. So you say low voltage. We discussed it a little bit, right? Low voltage, would that be 5 volts? Raise your hands. Less than 5 volts? Yeah. Between 5 and 15? Above 50? Above. More than 50? More than 200? No one. Okay, let's see. The low voltage directive was not made by electronics or programmers. It was made by people from energy. And low voltage for people from energy sector is and this. So low voltage is everything below 1000 volts. Between 50 and 1000 volts. So anything below 50 can't kill you unless you are sitting on a bathtub, right? Very well grounded with your wet feet, right? And 1000 volts, more than 1000 volts will definitely kill you if you touch it, regardless of your shoes or anything. Okay, so this low voltage directive is covering all the electronics, everything that we plug into a wall socket. That would be a general rule. Or if it is powered by batteries, between 75 and 1500 volts. Now, what it doesn't cover? It doesn't cover explosives, because it is a safety directive, right? So explosives shouldn't be safe, right? In general. It doesn't cover medical devices because it has its own directive. Electricity meters, elevators, electric fences, and my favorite, custom-made evaluation kits for scientific purposes. So scientific instruments can be dangerous because of that. So how do we assess it? We test for electricity surge, so the danger of getting struck by the high voltage, the high temperature, the fire, the explosions or the lasers, I don't know exactly, the mechanical problems, mechanical threats, the UV exposure, the protection against rain, and so on. So all that is in low voltage directive, which is a little bit funny, because if you ask me, low voltage means anything about electricity. But here you also see the mechanical damage, you see the high temperature fire, which is not exactly the thing you would connect with electricity in the first place. Maybe yes, but not in all cases. So how is electrical safety maintained? Of course, in your house, you have your installation, which is protected by the RCD switch. And if your device is grounded, if you touch it, you will be okay. If the grounding fails and if you touch it, then the RCD switch will switch off. You always have to have 2 levels of protection. If one fails, the other must kick in. Right. So how do we achieve 2 levels of protection? First of all, we have class 1 devices, which are grounded devices like a washing machine, for example. It has a metallic case, you can touch it, and that metallic case has to be grounded. If this grounding fails, well, then you have another isolation layer between the cables and the case. If the cabling isolation fails, and if the case is grounded, then your RCD switch in your house will switch off. So we have 2 levels of protections. Then we have class 2 devices, which are plastic case devices, which you actually don't touch. I mean, if you touch it, it's not touching any conductive surfaces. And these are devices called double isolation devices, which means that inside your electronics is isolated from the case, and the case itself is isolating as well. But then, of course, you plug in the charger, and you can touch the tip of the charger on the other side, on the connector. You can touch it, right? What then? Yeah, well, then you have to have a transformer with a double isolation between the primary and secondary winding, because this will protect you as a user for this against electric shock. The third type of devices is called class 3 devices, which are powered by low voltage, like laptops or phones or any electronics that is using external charger. These are essentially safe if the power supply itself, if the charger is safe. Can these devices pose a health risk? Surely they can. I mean, low voltage directive is all about safety. So, for example, you have a power supply, and for some certain electromagnetic noise reasons, you can have a capacitor between the primary and secondary winding. And this capacitor, you can imagine, it's like a few micrometers of 2 plates as a capacitor between the dangerous side and the safe side. So this capacitor has to be really good, and therefore it's expensive. So what do people do then? Especially in most of the Far East products you buy today on AliExpress and stuff, they come without this capacitor because they rather see the device to radiate a little bit over the limits, like 100 times, than being it dangerous for a user. Because if somebody gets killed, who will you blame, right? Who will you go complain when you're dead, right? I mean, okay, your parents or anyone. Who would you complain if you get killed by such a device? In Shenzhen? Okay. So, especially when we were talking about medical electronics. Imagine you are now connected with wires to a certain device that is plugged in the socket. Now you are really well connected. And if something goes wrong and the voltage goes across your heart, then I wouldn't be in your place. So in medical devices, there are really strict regulations regarding that. And that's why medical devices are covered in a separate directive in European Union. And we have recalls from stores. If some product becomes dangerous, or they found out it's dangerous, the inspector finds that out, they will be recalled, and you have to return all these devices back to the producer, and then producer just changes the label and sends all devices back. That's what happens. Because inspectors in Slovenia, they maybe have budget for 2 testing a year. So imagine you can have, each week you have a few of such products that are redrawn from the store. And then nobody, if you just change the label and put it back, it can get easy. Especially if you're importing from Far East. Can such devices pose a security risk? That's your conference all about, right? Well, think about it in this way. What does this have to do with low voltage security or low voltage devices in general? Well, you can use online platforms to make a deal with all the people in Slovenia, for example, to turn on their kettles exactly at 5 o'clock in the afternoon. Everyone, exactly at 5 o'clock in the afternoon. Exactly, it's very important. And then you will have extra 2 gigawatts of power consumption in the electricity grid. And if this happens, it doesn't matter if this electric heater is compliant with safety or not, it will cause a major problem in our grid. Because the frequency of our grid is 50 hertz, and now we have extra load. Then the frequency will drop, and then we will have to start importing the energy from the neighboring countries. And if this is done in a matter of seconds, we're just not that fast. Which means that we have to increase the power generation from our power plants. And for example, our oil or gas power plant, the only one we have in Brestanica, can be turned on in seconds. But the others, the hydropower plant take 10, 20 minutes to ramp up, while the nuclear power plant will take days. So in that few second glitch, you will certainly shut off part of the grids, we'll have a blackout, and we will hack the system really hard. So hackers, think about it. If you manage to persuade 1 million people to drink tea at 5 o'clock in the afternoon, well, this will be a major issue in Slovenia, but very little problem in England. Because in England, they know already that people drink their teas at 5 o'clock in the afternoon, and they turn on their extra power plant just for that, just 5 minutes before. Okay. What about other safety, like fire, right? Like batteries? Is a phone low voltage device? That's a question to you. No, it's not. So, can it explode? Yes. So what's the deal? Well, our politicians in Europe were thinking in Brussels a lot about it. And they said, okay, what does phone have than other devices that are covered by low voltage directive doesn't have? And they were really smart, and they said, okay, it has wireless interface. Wow. As hundreds of other devices you can buy every day, right? And mainly because of that. Because we are importing lately so many gadgets from Far East, they're very cheap, and they are really bad, and we throw them away immediately or after a few months, and they come with quite a problematic safety measures. For example, one colleague, or I know one guy, who bought a security system from AliExpress and installed it in his house. That security system had a battery which caught fire, and that battery fell down on a balcony where he had a couch, and that couch caught fire, and then the house went down. Right. So our great politician said, okay, if all these devices that are coming from Far East, including phones, have wireless interfaces, let's put a new directive which is called radio directive. And they said, okay, in the radio directive we are covering everything that has a radio receiver, radio transmitter, or both. And they say, okay, let's put safety, EMC, and radio requirements in the same directive and say, okay, this is now about everything. So your wireless devices have to be safe, they should not catch fire, they should be safe to use, they should also include cybersecurity. Okay, what doesn't it cover? Well, if it is a radio device, then surely it doesn't cover those devices which are connected by wire, right? What else? The radio amateur devices, the marine equipment, the aviation equipment, and my favorite, the experiments that are made for scientific purposes. So what do they test? They test for the connectivity. Wireless devices should be intercompatible. They should communicate with each other, otherwise they are useless, right? What else? Well, they should use the spectrum really, really wisely, not to spread too much power into unwanted regions of your spectral range. And the one which was quite controversial, they should use very specific, universal charging ports, like USB-C. That's why our iPhones have to have USB-C in Europe. And it was quite a big dispute between Apple and Europe. What else? Cybersecurity. Safe passwords, safe storage of the certificates, updates, all that. And GDPR. So safe storage and use of your personal data. Ability to erase your personal data if you sell your smartwatch to your colleague or enemy. Possibility to call emergency call services, and ability or the features for disabled people. All that should be included in the radio directive devices. How strange is that? And updates, of course, secure updates. So if your device has a radio, now it should comply with all these rules just by adding radio. Okay, so what does it mean when you are producing something and you want to add a radio module in your device? Well, what you can take, of course, you can take a ready-made radio module. You insert it in your device, you solder it and stuff, and then program it and use it. But then, if this radio device which you're using is not certified, then you have to do all the certification by yourself, which means it costs around 20,000–30,000 euro for a prototype. Of course, you can buy a ready-made on the market USB or something else wireless key, and you just plug it in and you say, okay, or you sell those, you sell a device with a USB separately, and then you sell this USB key separately, and you say, this is not my radio device, and a user plugs in, and then the user is responsible for, all that. So this is another option. And of course, the most safe option is buying a certified module, insert it in your device, and then you just have to certify very essential things, like not the whole certification procedure, just essential parts like spectrum and the power, the radiation power. does adding a Bluetooth module change anything if you are inserting now in your existing device a Bluetooth module? What does it change? I will give you an example of our producers in Slovenia, actually, that is producing kitchen white equipment, small kitchen equipment, like blenders. What is wrong with that blender? It has a button. It has a scale. You can do stuff with it. You can blend, make smoothies and stuff. Good. Why do we add? What do we test? For the EMC, for example, we test frequency spectrum from 30 megahertz to 1 gigahertz. And that's OK. But people want apps, because they cannot make a smoothie without an app, right? Because you get a recipe, and then you sell your data to and stuff like that. And then this device becomes a radio device. It's not longer a low voltage device, it is a radio device. And it has to include some measurements for the radio spectrum. And for Bluetooth, it's 2.4 giga, so the measurements have to be done up to 6 giga. Wow. Is that a problem? Yes. Because the lifetime of the motors with these blenders is around 100 hours. And the motors are the cheapest motors you can get. And they use brushes. And since they rotate, the brushes generate sparks. And these sparks are the best radio transmitters you can get. Really wide spectrum. And they transmit all the way up to 6 gigahertz and more. And the producers have now real hard problems reaching EMC requirements because they introduce Bluetooth modules in their everyday gadgets. So, does non-compliant radio equipment pose a health risk? Well, they say you may get a headache. We call this thermal effects of radiation. And yeah, you can get a headache, maybe. Who knows? Nobody actually doesn't have a definite answer to that. How risky is using your phone just because of the radiation it gives? But I must tell you, the phones have really inefficient antennas. Really inefficient. So if you could just get a phone with an extractable antenna, that would be a real breakthrough. And I remember 20 years ago, we used to have such phones, actually. But then somebody decided, I think his name was Steve, that using a phone of a square shape is a must. And no sticking parts. Therefore, phones nowadays are really, really inefficient in their radiation and usage of battery and stuff like that. So, using your phone next to a very health critical device may cause interference if the device doesn't meet the requirements for EMC. And this is something that we should, let's say, at least avoid, because we never know. But that's it. So, what about security? Well, the radio directive includes security as well, which means that, for example, Android set-top box for TV. I used to have such an example. My neighbor had such an Android set-top box, and it was infected by some virus, and it started to send loads of traffic on our local GPON network, optical network, and we couldn't watch TV at 9 o'clock in the evening during the Olympics. It was really, really bad. Well, I mean, it was inconvenient, but nobody died. But think about this. We have now in Slovenia 1.5 gigawatts of installed photovoltaics. 1.5 gigawatts. It's comparable to the kettles that you would turn on and impose 2 gigawatts spike, but turning off 1.5 gigawatts at once at noon would cause the same effect. And these inverters that are used have been initially, like 20 years ago, we were buying German inverters. And then we switched to Israeli, the Solar Edge. And now we are buying Chinese inverters. And they all come with the same Wi-Fi interface. All of them. It looks like that. Now imagine Xi Jinping, or what's his name? And then we have a catastrophe. So it's a real threat. It's not something that, it's a threat people in energy sector are talking about a lot. Because they are used to machines that work for 50 years, and now we are introducing machines that come from the IT sector, which we all know that they last maybe for a year or two, like phones and laptops. And now combining two worlds of a world of machines that last for 50 years and the world of machines that runs maybe for 2 years and then die. Combine these two is also changing the mindset of people. Finally, Europe decided that giving cybersecurity, demanding cybersecurity from wireless devices is not enough, because not all devices are wireless. So they introduced in 2024, they introduced Cyber Resilience Act. And this Cyber Resilience Act is covering all products with digital elements. Every product that has a connectivity of any kind, even just through a display, when you can maybe just enter your password, that has a certain software, and maybe you update it with a USB key. It doesn't mean that it needs to have a Ethernet or wireless connectivity. And these products which are on the market are covered by Cyber Resilience Act. And it includes all electronics like phones, gadgets, smartwatches, smart house gadgets, everything. Software, from operation systems to any level of software, and also components like microcontrollers, microprocessors, the chips for routers, the drivers for those. These are all covered in Cyber Resilience Act now. What are the components that are not covered? Well, like components that cannot be hacked, like light bulbs, if they're not smart, right? So everything that's not smart is okay. The open source software is not covered if it is not commercially available. So everything you put on GitHub, you're not legally binded to this. But if you use a piece of source code in your code and you're selling it, then you should take care about cybersecurity. So this is important. What else? Well, medical equipment has its own coverage. The cloud storage systems as well. The automotive, the cars have their own certification. But if you are selling products to be put into car by the user, then these products should comply with cybersecurity. The railways, avionics, and military, these all have their own standardization. So what do they check? What is checked by this Cyber Resilience Act? First of all, the security has to be done by design from the start. It's very similar to the safety, the low voltage directive. You have to start immediately when you are starting designing your product. You have to think about safety, and here you have to think about cybersecurity. For example, you are using components. For example, you have to take a microcontroller which has a secure core, which has a secure boot, which has trust zones and stuff like that. These are all things you have to start at the beginning. What else? You have to maintain your cybersecurity for the whole life cycle of the product, which is usually 5 years. And you have to make sure that you do all the updates necessary. You have to make sure that you report all the issues in 24 hours when they happen. And you have to do risk analysis. You have to do the whole documentation on the risks that may happen for your device. And this is the basis for the CE marking. And you have to inform your customers how to safely use the product, not to be vulnerable to the cyber attacks. It's like in electronics, let's say, if you take, I don't know, a blender, it will maybe say in the user's menu, don't put your hand inside or something. Or if you take a hairdryer, it will say, don't do the hair drying in your bathtub or something. Don't put it in the water. So you can always use electronic device to kill yourself if you want, right? I mean, it can be done, but this is certainly violating the user instructions. So in terms of cybersecurity, it's the same. You have to have instructions to how to safely use it, and then if you break those, then you are responsible, otherwise you're not. And this is important. The cybersecurity goes from the producer. So the producer is the one that's responsible, but not only one, also distributor and importer. So if you're now importing stuff from China, you become an importer. You're putting stuff on the market in Europe, and then you are a responsible person. So if something goes wrong and your router is now hacking half of the city, then who is the responsible? Not the producer now, because you cannot reach it somewhere in Shenzhen. The inspector will first go to you who imported that product and didn't check the papers properly. And finally, and this is what I will end with, the Cyber Resilience Act is now shifting the burden for responsibility of cybersecurity from users to producers, importers, and distributors. And it will come in act in 2027. So next year, December, every product put on the market will have to certify it by Cyber Resilience Act. And what's even more important, the fees will be really high. Think about it. 2.5% of turnover, or up to 15 million euros, will be the fee if you put on the market a component that is not certified by Cyber Resilience Act. That's quite a lot, isn't it? So that's all I wanted to say. Thank you very much.
Thank you, Marko. Do we have any questions, maybe? Yeah? I'll start here and then go to you.
With the fees, you said 2.5% of global turnover or $15 million. How is it decided which one? Is it whichever is the highest, whichever is the lowest?
Whichever is the lowest, I think.
Okay.
Yeah. But don't take it for granted. It's the other way. It's the other way. Sorry. It was just a nice wish.
So with like the inflood of Chinese components and from every market, is there an actual entity in Europe that actively checks that like components are meeting the standards and like penalizes them, the importers, if they're not? Like, because as far as I know, every country has some of these entities, but they're usually like, they don't have the capacity to actively check.
It's not, there is no such an entity that would be really doing it as a base, let's say, mission. There are inspectors, and usually when do inspector act? When somebody reports it. So you have, a competitor will report you, for example, if you're selling something online, for example, some of the gadgets that you made at home, you will get a report from your competitor, and the inspector will come to your house and say, okay, can you show me your documentation? And you will say, what documentation? What's that? Who am I? Stuff like that. But yeah, sometimes inspectors are doing regular checks, but these checks may be 2 times a year. They get budgets and they go, let's say, into supermarket and they buy computer power supplies, tens of them, and they take them to the SIQ and they test for safety, EMC, and it turns out that more than 50% are not compliant, even though they are put on the shelves. So this is a real issue. And now with the stores that you were buying very cheap products, it gets really worse because it's totally unregulated and it's so much, it's flooding the market that there is no way to act on that.
So when it comes to the security of software and firmware, how exactly is it going to be enforced? Like, what will be the criteria? Because if software is, for example, proprietary and it's super complex, like an external entity can't really, check whether it's safe or not, and whether it has a backdoor or something like this.
Yeah, I don't know exactly the answer to that. It's a matter of trying to, let's say, if you want a certification of the highest level, you will send this software with the source code and everything to a agency, to a company that will do the testing. And if they do not break in 1 month's time, you will get a highest level certification. This would be one way. Otherwise, I mean, I was working mainly on the safety for medical devices in some time in my life. And we were doing certification for USA, and for those we had to send in the source code, and they were checking the source code.
And we have 2 more questions on this side.
Thank you. So you mentioned this directive is a law. What about standards? How to do it? For example, for local producer of such an equipment.
Well, when the law is enforced, the standards are developed in parallel. So the law and the standards are always working hand in hand in Europe, which means that European Commission, when it is giving the law, before that it already instructs the standardization organizations to adapt either the worldwide standards or develop their own. So when the law is enforced, the standards are already prepared. And then the standards are renewed and so on and so on.
And I think we had 1 more question.
So what is happening? What will happen when CRA meets OT, existing OT installations?
Well, I think that the producer will have to decide whether to upgrade their existing products in order to meet the Cyber Resilience Act. For those who are already on the market, of course, you cannot do much, right? But if they have software updates already prepared, it's easier. But I don't think that they will get fined if they have put a product on the market already. But for the new product they are selling, they will have to meet that criteria. So they will have to redesign if they did not. So that's why we have a 3-year time window. So the Cyber Resilience Act started in 2024. So the 3-year time window is for all the producers to adapt to the new standards, to the new regulations.
Okay, that's for producers, but for the ones which are installed, is there any period, or they can be just installed, just patching? We know how it is with OT, it's very hard.
I don't think there will be some going on there much. So those who are already installed, they will just be there. And maybe they will, in some time, they will say, okay, I don't know, devices with Windows 11 should not be part of the infrastructure anymore, or something like that. Maybe. But yeah.
Thanks.
Are there any more questions, maybe?
Oh, so
okay, and I think this will be the last question then.
That my driver went home, otherwise he would answer these questions.
Hi, thank you for the presentation. You presented a lot of issues with the current regulatory framework. I'm wondering, what do you think a better alternative or a better setup would be?
I think the law is written well, with some holes which are now filled with the Cyber Resilience Act, but the problem is how to implement it in practice. That's always the case. So if we have a law which we all obey, then there is no problem. But as I said, with a bunch of cheap Chinese stuff coming in, with no intention of to following the rules, then we don't know what to do. I really don't know. Maybe just put on the customs, and people won't buy it anymore. But how? I mean, who is the importer if you buy on Temu? You cannot legally bind anyone for the response, to be responsible. Yeah.
Yeah, I think this is all the time we have for the questions. So if there are any more questions, please find Marko at lunch or after lunch. Thank you, Marko.